Okay, this video is to help you with the trouble with the law of sines. The law of sines is a great formula, but it does have one issue you need to watch for, and that is when the SSA case presents itself. When you are given two sides, so note over here A and B, and the angle opposite one of those sides. So it's not the angle between, it's not SAS, it's the SSA, or side-side angle formula. So if we are given the side or the angle 40 degrees, that is going to be one of the locked in parts of our triangle right now. We can't change that 40-degree angle. We also know that its opposite side is going to be 12, so the length of that side can't change. And one of the other sides is also given to us, so we know that side little b is 15 right here, which means the length of this side can't change and the length of this side can't. Technically, side AB, or what we call little c down here, could be longer or shorter, just depending on where that 12, that length of 12 side touches. And if 12 is too short, we may or may not be able to even make a triangle. And again, you would find that out when you tried to set up the law of sines, which we could do right now. Sine of 40 degrees is to side 12 as the sine of angle B is to side 15. If you do a couple of quick calculations, a little cross multiply, and divide, you'll find out that sine B will be equal to 15 sine 40 divided by 12, and in that case, angle B will be equal to the inverse sine of, again, divide your 12 over 15 sine 40 degrees all over 12, which means that angle B will be equal to 53.464 degrees. Now the problem comes in that when you have an acute angle, as defined here, an acute angle whose opposite side is smaller than the other given side, the other adjacent side. So the opposite of 40 degrees is 12, and 12 was less than 15. The problem comes in that that doesn't define just one triangle. If we took that side of 12, again, we didn't lock angle C. If I take a side of length 12, so notice the orange side is exactly the same length as the green, and we sort of swing it as we are here, I can swing that over, and as I said earlier, side AB could have been longer or shorter depending on where that side of 12 crosses. And because we can actually draw it instead of outwards, making this green triangle as it is, we can actually draw that sign sort of inwards on the triangle. We are basically defining a new triangle. We're defining a triangle here to point B prime, as we'll call it. And if we want to define the measure of angle B prime, again, we wouldn't be able to use the law of sines here. Even though it seems like it would set up nicely, the first answer we got is 53.464 degrees. Your calculator is not going to give you another answer to that. But the nice part is you can actually define that triangle. Again, the triangle that looks more, instead of outwardly defined, it's more inwardly defined, such as this one. We can find that angle using what we already know. If I know that angle B, right, was equal to 53.464, and these two sides are both 12, this is an isosceles triangle, which means that side or angle B could also be written over here, because base angles of isosceles triangles are equal. Well, if this angle from C to B prime to B is 53.464 degrees, right? Well, that just makes a nice straight line from A to B. We can just subtract that, 180 minus 53.464 degrees, and find out that the measure of angle B prime will come out equal to 126.536 degrees. And basically, because of that SSA scenario, we find out that we have two different possible angle B's. Because given that information, an acute angle, opposite side is shorter, it doesn't define just one triangle. That is not a congruence theorem from back when we were in geometry. Again, it doesn't take much to find that second angle, and now that we know that other angle, technically we could solve the entire green triangle using our 53-degree angle. We could also solve this sort of green-green-orange triangle, this sort of sliver of a triangle, taking advantage of our 126.536-degree angle. I hope that helps you describe the SSA case, and again, it'll help you to just keep practicing those problems and keep an eye open for, again, the calculator. This is the one time that's not going to be much help for you. It will help you with the law of sines, but it won't help you recognize two triangles: an acute angle, smaller opposite side compared to the adjacent side, smaller given side here compared to the other side given.